Hello friends, welcome to Actual Abundant Academy. In the last lecture we have discussed up to question number 4. So we will discuss question number 5 onwards in this particular lecture. So basically we are discussing the problems on the D'Alembert's principle. So let us discuss question number 5. A plank of mass capital M is initially at rest along the line of greatest slope of a smooth plane. So that smooth plane is inclined at an angle of alpha to the horizontal, and a man of mass capital M dash starting from the upper end walks down the plank so that it does not move. So when the man is moving downward, this plank is at rest. Okay, so let us draw the smooth plane. So we have a smooth plane like this. Okay, and it is inclined at an angle of alpha to the horizontal, and there is a plank of mass capital M. So there is a plank of mass capital M. Okay, and this is the upper end of the plank, and this is the bottom end of the plank. This point A. Okay, this is point B, and a man of mass capital M dash. So there is a man of mass M dash. This is M dash. He is at point A. Okay, so we have to find the time taken by this man to reach point B. Okay, so this is the final position of this man. Okay, so time taken by this man to reach point B is, let us consider this time is t. Okay, so this t we have to find, and that t is equal to this expression 2 m dash a upon m plus m dash into g sin alpha. Okay, so let us find this. So let us consider the man moves a distance x. Okay, let us consider the man moves a distance x. Okay, so this distance we have taken as x. Okay, so this is our reference point. Okay, this is origin. We are taking in this particular, moving in this particular direction. Okay, so let us consider x bar is the position of the center of gravity. X bar is the position of center of gravity. X bar. Okay, and this is the position of the center of mass of the plank. The mass is concentrated at this particular point. So this is capital M, and mass of the man is m dash. Okay, so let us consider x bar as the position of center of gravity. Okay, so let us find the position of center of gravity. Okay, so the man of mass m dash has reached at this point. Okay, so it has moved a distance x. So we have to find the position of center of gravity. Okay, so the position of center of gravity when the man, the position of center of gravity when man moves a distance x. Okay, so we have x bar is equal to m dash into x, m dash into this distance is x, so m dash into x plus capital M is the mass of the plank. The mass is concentrated at a distance of a by 2 upon m dash plus capital M. Okay, so we have m dash plus m into x bar is equal to m dash x plus m a upon 2. Okay, so let us further simplify this. So we have, let us differentiate this twice. Okay, so differentiating this equation twice. Okay, so we have m dash plus capital M into x bar double dot is equal to, this will be 0 because this is constant, so m dash into x double dot. Okay, so let us take this as equation 1. Okay, so now let us find the equation of motion of the center of gravity of the system. Okay, let us write down the equation of center of gravity of the system. Okay, so we have from Newton's second law, equation of center of gravity of system. Okay, so we have, okay, from Newton's second law, the equation of center of gravity of the system, let us write down. Okay, so what are the forces that are acting here? Okay, so we have this as mg sin alpha, and on man of mass m dash g sin alpha. Okay, so when the man is moving in the downward direction, so we have the whole system, mass of the system is m dash plus m d2x upon dt square. Okay, so the center of gravity is moving in this direction, the position of center of gravity. So we have d2 x bar upon dt square is equal to force. Mass into acceleration is force. So we have m dash plus m into g sin alpha. Okay, so this is the equation of the center of gravity of the whole system. So mass of the system is m dash plus m into double differentiation of the position of center of gravity is equal to the force. Okay, so we have this as m dash plus m into x bar double dot is equal to m dash plus m g sin alpha. Okay, so from equation 1 we have m dash plus m x bar double dot is equal to m dash into x double dot. So we have this as, this we can write as m dash into x double dot is equal to m dash plus m into g sin alpha. Okay, so we have m dash d2 x upon dt square is equal to m dash plus m into g sin alpha. Okay, so let us integrate this. So on integrating we have m dash dx upon dt is equal to m dash plus m into g sin alpha into t plus c1, constant of integration. Okay, so when t is equal to 0, the man is at position A. Okay, so at that point the initial velocity is 0. So we have dx upon dt is equal to velocity is 0. So we have 0 plus 0 is equal to c1. So this means c1 is equal to 0. So we have the equation as m dash dx upon dt is equal to m dash plus m into g sin alpha into t. Okay, so let us further simplify this. We have this as m dash dx upon dt is equal to m dash plus m into g sin alpha into t. Okay, so let us further simplify this. So we have m dash into dx is equal to m dash plus m into g sin alpha into t dt. Okay, so we have to find the time taken by this man to reach point B. Okay, so initially at x is equal to 0. Okay, initially the man is at point A. Okay, so at t is equal to 0 we have x is equal to 0. Okay, so let us consider capital T is the time taken by the man to reach point B. Okay, so at point B we have x is equal to A and this we have capital T. Okay, so we have m dash into A is equal to m dash plus m into g sin alpha into t square upon 2. This limit is capital T and 0. So we have m dash into A is equal to m dash plus m dash plus capital M g sin alpha into capital T square upon 2. So from here we have capital T is equal to 2 m dash into A upon m dash plus capital M g sin alpha. Okay, under root. Okay, so this is the total time taken. This is the total time taken by the man to reach point B. Okay, so this is being asked in the question. So you have to show that the total time taken is 2 m dash A upon m plus m dash g sin alpha. So let us go back to the question. Okay, so the total time taken is 2 m dash A upon m plus m dash into g sin alpha. Okay, so we have this expression. So we have t is equal to 2 m dash A upon m dash plus m g sin alpha. This is the total time taken by the man to reach from this position, from position A to position B. Okay, so this is the final position of the man. So the total time taken is so capital T is the total time taken to reach from point A to point B. Okay, so let us discuss question number 6. Okay, so let us discuss question number 6. A rod of length 2a is suspended by a string of length L attached to one end. If the string and the rod revolve about the vertical with uniform angular velocity and their inclinations to the vertical be theta and phi respectively. Okay, so let us draw this. So we have a rod of length 2a is suspended by a string of length L. So let us consider this as a string and this as rod. This is our axis. Okay, so this angle is, the angle of inclination is theta and phi. So this is theta and this is phi. Okay, so this is our rod of length 2a. So this whole length is 2a. Okay, so this is a by 2 and this is a by 2. Okay, so we have, let us consider the mass of the rod as m and the density as rho. So we have rho is equal to m upon 2a. Okay, so the weight will apply from here. So this is capital Mg. This is the weight. Okay, so let us take an element at an distance x. Okay, so let us take let us name this. So we have, let us take this as O, this as A and this as B and this point as C. So let us take an element dx at a distance of x. Okay, so this element is dx. Okay, this element is dx. So the elemental mass dm will be rho times of dx. This is the elemental mass. Okay, so this is the elemental mass, dm is equal to rho times of dx. So this whole system is rotating about the vertical axis like this. Okay, so we have a this is our point. Okay, so this is our string and this is our rod. Okay, so the angle of inclination is theta and this angle of inclination is phi. Okay, so this whole system is rotating about the vertical axis. Okay, so we have this as angle of inclination as theta. The angle of inclination of string is theta and the angle of inclination of the rod is phi with the vertical axis. Okay, so this whole system is rotating with an angular velocity omega about this particular axis. Okay, so let us take the angular velocity as omega. So since the angular velocity is omega, so the elemental mass, the forces that are acting on the elemental mass is the centrifugal force. Okay, so here we have to find the reverse effective force. So the effective force is centripetal force which is acting in inward direction. So opposite to this we have the reverse effective force, that is the centrifugal force. Okay, so we have the axis like this. So distance of this point from this axis is, so this is x, so this distance will be x sine phi and this will be, this whole length is L. L is the length of the string, so this will be L sine theta. The whole length is L sine theta plus x sine phi. So we have this force as centrifugal force. Let us take this as capital F. So this is equal to, so this force is equal to m omega square r. So the elemental mass is dm into omega square, m omega square into this distance, because we have to find the we are finding the centrifugal force about this particular axis. So this is the whole distance. So this is L sine theta plus x sine phi, L sine theta plus x sine phi. Okay, so this is the force. Okay, and we have the tension in the string as capital T. Okay, so let us resolve this. So in this particular direction we have T cos theta and this as T sin theta, because this angle is theta. So we have, let us resolve. So resolving horizontal and vertical forces. Okay, so we have the vertically we have T cos theta is equal to mg, capital Mg. Okay, so the only force that is acting in the downward direction is capital Mg, because we have considered the mass of the rod as capital M. Okay, this is equation 1. So and horizontally we have T sin theta. So that horizontally we have T sin theta. T sin theta is equal to this centrifugal force. So this is dm into omega square. Okay, so the length of rod is A. Okay, so we have to, sorry, the length of rod of length 2a. So we have this as this will be A. Whole length of the rod is 2A, na? So this will be A, and AC will be A. So we have T sin theta is equal to this force. So we have dm is equal to rho times of dx. So we have rho omega square into L sin theta plus x sin phi into dx. Okay, so the integration is from rho dx is the mass. So we have placed dm is equal to rho dx. So we have the integration from 0 to length of the rod is 2a. Okay, so this is 0 to 2a. Okay, so let us integrate this. So T sin theta is equal to rho omega square into L sin theta into x plus sin phi into x square upon 2. So the limit is 2a and 0. So we have T sin theta is equal to rho omega square into L sin theta into value of x is 2a plus sin phi into 2a square upon 2, that is 4a square upon 2. So this gets cancelled to 2a square. Okay, so 2a we can take out. So we have T sin theta is equal to 2a into rho omega square. We have L sin theta plus a sin phi. Okay, so we have T sin theta. T sin theta is equal to and we have rho is equal to m upon 2a. So we have 2a into rho is equal to capital M. So 2a into rho, this is capital M. So we have m omega square into L sin theta plus a sin phi. Okay, so from here we have, this is equation 1 and this is equation 2. So let us divide equation 2 upon equation 1. So equation 2 upon equation 1, we have, okay, so equation 2 upon equation 1. So we have T sin theta upon T cos theta. This is tan theta. Tan theta is equal to capital M omega square L sin theta plus a sin phi. Okay, upon mg. Okay, so from here we have omega square is equal to tan theta into g upon, this is L sin theta plus a sin phi. Okay, so this is the value of omega square. So now let us apply the moment about point A, this point. Okay, let us apply the moment. So we have the value of omega as omega square is equal to, let us rub this. This is not required. So value of omega square is equal to tan theta into g upon L sin theta plus a sin phi. Okay, let us further simplify this. Let us take the moment about point A. So taking moment about point A. Okay. Okay, so when we take moment about point A, we will get rid of this T cos theta and T sin theta. Okay, so let us take, so we have the forces capital F and mg. Okay, so this is the force F, so this distance will be, so we have the moment as r cross F. Okay, so this is capital F and this distance is x of this as x of cos phi. Okay, so this distance is x of cos phi. Let us name this as d. So AD is x cos phi. Now in case of this mg, we have the force as mg and distance from this point A is, this whole distance is, so this AC is A, so this value is A, so this will be A sin phi. Okay, so let us write down the moment. So we have r cross F, so we have x cos phi into F. Okay, so in this case we have the force in this direction and r in this direction. So the r cross f is anti-clockwise, so this is positive. Okay, now in case of this mg, we have the force in this direction and the r in this direction, so this is clockwise. Okay, so this is negative. Okay, so we have minus of capital mg, minus of capital mg into r cross f है ना. So this is a sin theta, a sin phi, a sin phi. So this distance is a sin phi into capital mg. Okay, so we have the r vector in this direction and force in this direction. So r cross f is in this direction. So this is clockwise. So this will be negative. Let us place the value here is equal to 0. So we have x cos phi into f. So f is this one. So we have dm is rho into dx. So rho omega square into L sin theta plus x sin phi into dx. Okay, so this is from 0 to 2a. Integration is equal to a sin phi into mg. Okay, so we have rho omega square cos phi into L sin theta into x into dx, x into dx plus rho omega square cos phi. So we have x dx, and this is sin phi into x square dx. Okay, so integration is from 0 to 2a is equal to a sin phi into mg. Okay, so let us further simplify this. So we have rho omega square cos phi into, this is L sin theta, L sin theta into x square upon 2. So this will be 2a whole square upon 2, and this is plus sin phi into x cube by 3. So this is 2a cube upon 3 is equal to a sin phi into mg, capital mg. Okay, so from here rho omega square cos phi into, this is, so 2a square we can take out. So this is 2a square means 4a square. Okay, so this is L sin theta into half. Okay, plus this is sin phi into, this is 2a upon 3. Okay, 2a square we have taken out. So 2a square, so this will be 2a upon 3. And from here we can take out 2 outside. Okay, 2 we have taken out. So this will be 4. Okay, so this is 2a square. And this is a sin phi into capital mg. So from here we can cancel out a. And we have rho into 2a is m. So m omega square cos phi, m omega square cos phi into, this we can write as 3l sin theta plus 4a sin phi. Okay, upon 3. This we can write as, so this is equal to sin phi into capital mg. Okay, so now we have the value of omega square. Let us place the value of omega square. Value of omega square. So we have m upon 3 into cos phi into 3l sin theta plus 4a sin phi. Okay, into omega square is tan theta into g upon, this is L sin theta plus a sin phi. Okay, is equal to sin phi into capital mg. Okay, so from here this gets cancelled, mg. So from here G gets cancelled and this M gets cancelled. So we have and here is we have cos phi and here is sin phi. So this we can write as tan phi. So we have 3L sin theta plus 4A sin phi into tan theta, okay, is equal to, so we can divide by cos phi. So this is tan phi, okay, and 3 we can take here. So this is 3 tan phi. 3 tan phi upon and 3 tan phi, and we can multiply this with L sin theta plus A sin phi. Okay, so let us further simplify this. So we have we can write down here as, let us expand this. So we have 3L sin theta tan theta plus 4A sin phi tan theta is equal to 3 tan phi L 3L tan phi 3L tan phi sin theta plus 3A tan phi sin phi. Okay, so let us take 3L into 3L. So we can write down this one. Okay, so we can take this one, this term in LHS part, so RHS part. So this is 3L into, so this is equal to 3L into, so this is tan phi 3L into sin theta. Okay, so we can take it here. So we have 3L into this term and this term. So we have 3L sin theta into tan phi minus tan theta is equal to, from here we can take out A sin phi. So we have A sin phi into 4 tan theta minus 3 tan psi. Okay, so we have 3L upon A is equal to 4 tan theta minus 3 tan phi into sin phi upon tan phi minus tan theta into sin theta. Okay, so we have to show this expression. So we have, let us go back to the question. Let us compare these two terms. Okay, so we have 3L upon A is equal to 4 tan theta minus 3 tan phi. 4 tan theta minus 3 tan phi upon tan phi minus tan theta into sin theta. Okay, so this is all about the problems on the D'Alembert's principle. Thank you.